Hey everyone, welcome back for another video. Today we're going to talk about the derivatives of inverse trig functions, things like sine inverse, cosine inverse, and so on and so forth. I'm going to show you where sine inverse comes from, but ultimately it's going to be your job to memorize the 6 formulas that I give you here today. But first, let's see where sine inverse comes from. So remember, inverse functions just exchange the domain and the range. So really, y equals sine inverse of x. I can rewrite it like this. X is the sine of y. And one thing we want to establish is that when we deal with inverse trig functions, we're going to deal with principal values only. And so we need to remember that for sine inverse, that means that we're dealing with just the right side here of this unit circle from negative pi over 2 to positive pi over 2. So that's kind of what we're looking at here when we talk about these inverse trig functions. So if x is sine of y, and I want to find this derivative, well, I'm differentiating with respect to x. So the derivative of x is just 1. And the derivative of sine y is cosine of y. But since this is with respect to x, I need to throw a dy dx in there, just like we learned about with implicit differentiation. Now, when I solve for dy dx, I get 1 over cosine of y. Now, that's not helpful to me because I don't like formulas that involve y. I like explicit formulas. So I'm going to remember that I have a relationship between sine and cosine that looks a little bit like this. Cosine squared theta plus sine squared theta equals 1. So we have this Pythagorean identity. Now let's put it in terms of y. Cosine squared y plus sine squared y equals 1. Now check this out. I can solve for cosine of y by rearranging a little bit. And now when I take the square root of y, here's why it's important to remember that we're only dealing with principal values. Because our original angle had to be between pi over 2 and negative pi over 2, that angle is guaranteed to be on the right side of the circle. Well, guess what? Anytime we're on the right side of our unit circle, the cosine is going to be positive. So I actually don't need to worry about the negative, the plus or the minus, because my value is always going to be positive. So the square root of 1 minus sine squared y. Now, still not helpful, because again, I need to get rid of the y. So I'm going to go back to my original x equals the sine of y. And when I plug that in, all of a sudden, I have something I can replace cosine with that involves only x. So the derivative of sine inverse of x is simply 1 over the square root of 1 minus x squared. Now, this is a great formula, except it's only good if we know what x is. So we have to remember that x doesn't always appear in our inverse trig function. Sometimes we have a function. So like, for example, what happens when we have y equals sine inverse of something like 2x squared? And then we have something different in there. Well, then we have to consider the chain rule. So then what we would do is we'd say, well, let's let this be u. So anytime we had an x over here, we think of it as u equals sine of y. And so when we did the derivative of x, it was 1. Well, when we do the derivative of u, we have to consider it's 1, but it's du dx. So we would always have this du dx floating around, and we'd have a du dx here, ultimately meaning we'd have a du dx here, assuming that whatever we did, whatever value is in there. So this is the formula that I want us to get used to, and it's this idea that the chain rule is a big part of these inverse trig functions. So now that we've kind of seen where it comes from, how the chain rule applies, let me show you the formulas that you need to write down. So now is a great time to pause the video and maybe jot some of these equations down so that you have them. And I'll tell you right now, as you look at them, really you only need to memorize the 3 on the left, because the only difference between sine and cosine, you'll notice if we did all that, with the cosine, the only difference here would be that the cosine is negative. So sine and cosine, same deal, just one is negative. Same thing with tangent, cotangent's negative, cosecant's negative. It's the same formula, just negative. So you really only need to memorize one. And truthfully, on your AP exam, the 2 most common formulas that show up are sine and tangent. So if you can memorize sine and tangent, and then also remember, don't forget that chain rule. So that's the du dx, so the derivative of whatever we're taking the sine inverse of. Those are the two most common formulas that show up on your AP exam. Sometimes cosine will pop in, sometimes a cotangent, but more often than not, it's sine and tangent. So let's go ahead and put these into practice here. We're going to do a couple of examples, so now's a great time. If you haven't paused and copied these down, please make sure you do so. But let's take a look at this first problem. Now, recall that the derivative is just going to be 1 over the square root of 1 minus u squared times du dx. So, first things first, let's identify u. U is whatever we're taking the sine inverse of. So it's x squared, which means du dx is 2x. So here we go. I'm just going to plug it into my formula. Dy dx equals 1 over the square root of, now it says u squared. Well, okay, so 1 minus x squared squared times du dx, well, that's 2x. So when I clean all of this up, it's 2x all over the square root of 1 minus x to the 4th. So that's the answer that I'd be looking for. Nice and easy. Not too bad. So let's keep going. Let's try a couple more. Here's one that's the cosine. So remember, dy dx for cosine is going to be negative 1 over the square root of 1 minus u squared times du dx. So this is the formula that I'll be using for this one. So I'm going to identify u. U is just 1 over x, or x to the negative 1, which means du dx is going to be negative x to the negative 2, or negative 1 over x squared. So that's my du dx. So here we go, plopping everything into my formula. Negative 1 all over the square root of 1 minus parenthesis 1 over x squared, close my radical, times negative 1 over x squared. Now, we have to remember that we don't like fractions within fractions, so we're going to have to do a little bit more work with this one. So I'm just going to kind of algebra my way through it. A negative times a negative is a positive. So I'm going to have positive 1. I'll have x squared down here, and then the square root of 1 minus 1 over x squared. Now, my problem area is this guy right here, because we're in a fraction. So we can't have a fraction within a fraction. That's one of the AP simplification rules. So what I'm going to do is I'm going to take this value that's under the radical, and I'm going to get a common denominator. So I'm going to have 1 over the x squared hangs out, but then under the square root, this is x squared over x squared. So I'm going to make it x squared minus 1 all over x squared. Now I'm almost there. So the rule with radicals is that when you have a fraction under the radical, you can actually take that fraction and rewrite it as two separate radicals. So now I'm going to have x squared times the square root of x squared minus 1 over the square root of x squared, which I'll deal with that here in just a minute. But now I have it in a way where I can take that bottom fraction and flip it. So this is the bottom fraction that I'll be flipping, and I'm just going to multiply through by that reciprocal. So let's get a little bit more space here. Zoom in. So I'm going to take this entire value and I'm going to flip. So I'm going to multiply by the square root of x squared in the numerator, and then square root of x squared minus 1 down in the bottom. So it's a little messy right now, but here's what it ends up looking like. We have the square root of x squared in the numerator. We have x squared and then square root of x squared minus 1 down below. Whew, we're almost there. So now I need to consider the square root of x squared. Now remember, the square root of x squared is just the absolute value of x. So that's a rule that we have to live by. We can't just say that it's x. So anytime I do the square root of x squared, I should probably just leave it alone. I'm not going to do anything else with it. Because here's the deal. I can't cancel it with this x squared because it's trapped in the absolute value bars. I don't know if x is negative or positive. So if you don't want to go through that thinking, if you don't even understand what I'm talking about, then this is a great place for you to stop and not go any further. Now, when I look back at what's happening here, if my computer will let me zoom out just a little bit, I'm not given any information about x or the domain or anything like that. So x could be a positive or a negative value here. And I have no reason to believe that it is necessarily one or the other. So anytime I do the square root of x squared and I get the absolute value of x, I'm just going to leave it because there's nothing else I can do. And without analyzing it further, I'm kind of stuck. And I've never really seen an AP exam question that forces you to do this sort of thinking where you analyze, can I cancel, can I not? So at this point, I would just say, just stop here and call it a day. But you do have to get rid of fractions within fractions. That's a required simplifying step. So let's keep going. Let's try number 3. So I'm going to remember that the derivative of inverse tangent looks like this. 1 over 1 plus u squared times du dx. So I'm going to identify what u is. X squared minus 1, which means du dx is just 2x. So that's nice. So here we go. All I have to do is take the u and put it in. So 1 plus, I'm going to have x squared minus 1, all being squared, times du dx. Well, that's 2x. Ta-da! There we go. So when I simplify, I have 2x in the numerator, 1 plus. Now, please do not do anything else. Just stop right there, because you do not want to distribute that 2 in there. If you just simplify, if you get it down to 2 over x somehow, or 2 over x cubed would be the wrong simplification answer, I'll know what you did, and it'll make me cry a little bit, because when students think that you can take something like a minus b squared and just put the exponents to it, it's super duper sad, and you know, it makes me cry a little bit. There's my tears. Please don't make me cry. Oh, yeah, it's a sad day. Don't do that. You have to write it twice and FOIL it out. So I would just stop here. You don't have any fractions within a fractions. Boom, call it a day and walk away. Let's keep going. Now, like I said, sine, cosine, tangent, those tend to show up on your AP exam. This secant one, I don't even have it memorized, so I have to go back up and I've got to look at it. That's how infrequently it comes along. So let's take a look. Cosecant is 1 over the absolute value of u and then square root of u squared minus 1 times du dx. Whew. Okay, so we got 1 over the absolute value of u squared minus 1 du dx. There's my formula. So here's u. U is 5x to the 4th, which means du dx is, let's see, 20x cubed. Whew. All right, we can do this. So here we go, dy dx. Just going to plop everything in. 1 over the absolute value of 5x to the 4th. And then we'll have the square root of 5x to the 4th squared minus 1. Make sure you extend any fraction lines if you end up going farther than you think you are gonna. Times du dx, well, that's 20x cubed. So let's simplify. 20x cubed. All right, this is trapped in an absolute value, so we're going to have to think about this before we release it and simplify. But underneath here, we're going to have 25x to the 8th minus 1. I can't square root that. We're just going to leave that alone. But this value here under the square root, let's think about this. We have an even power and an even 5. If this value inside the absolute value bars is going to be positive no matter what, then we don't need the absolute value bars. If we had an odd power like an x cubed, when you cube a negative, it's negative. So you need the absolute value bars if there's an odd power or a negative value in there. But in 5x to the 4th will always be positive. So I can drop the absolute value bars if I don't need them, because if it's always positive, the absolute value bars do nothing for me. So I can actually cancel, and then I can simplify this right here. So here we go. We're going to have 4 in the numerator, and then in the denominator we reduce down to an x, 25x to the 8th minus 1. Ta-da! There it is. There's your answer. So sometimes we can get rid of absolute value bars if the value underneath will always remain positive. But unless you're sure, you can always just leave it and not worry about it, because not taking steps to simplify usually isn't going to harm you. Remember, so far our only two rules for simplifying are trig functions that are on your unit circle and fractions within fractions. Aside from that, if you were to stop, like right here, this is an equivalent form, it's fine. You would get full credit for that. And on your AP exam, there's no further simplification that's needed. So sometimes students will simplify incorrectly, and they'll actually simplify themselves incorrectly out of a point. So if you're uncomfortable with going those extra steps, it's good to know them so that on a multiple choice question you can find the right answer. But on a free response, it's actually maybe better not to simplify if you don't have to, so you don't open yourself up to making some mistakes. In any case, there we go. Remember that practice makes proficient. It doesn't make perfect. You're still going to make mistakes, and that's okay. Please don't ever be afraid of challenging thinking, or you don't grow without being challenged. And so some of this thinking is going to be like, whoa. But if I don't tell you now and you hear it later on in a higher level math, well, then I've done you a disservice, because hearing it now and not understanding is at least setting you up for better understanding in the future. So don't worry if you don't understand every little thing. You're going to get there, and it just takes hearing it over and over again. So the long and the short of it is, stick with it. You can do this. You've got this.